In this lesson, you will learn to factor polynomials by using the greatest common factor and by grouping terms. So we have learned how to factor numbers, right? But now in this lesson, we're going to learn how to factor polynomials. And the question is, what does that even mean? Well, it's kind of like the opposite of distributing. So we've learned how to distribute, right? Where we have 4x squared y, and times parentheses 2x plus 3y. Where to distribute, you take the 4x squared y times the 2x, and then times the 3y. So 4 times 2 would give me 8. X squared times x gives me x to the third power, and then you just have the y left over. And then 4x squared y times 3y, you have 4 times 3 to get 12. X squared doesn't combine with anything, and the y times the y gives me a y squared. So that is distributing. But in this lesson, we're going to go backwards, where we begin with this statement right here, and you're trying to work back to get an expression looking like this. And there are reasons for doing this that we'll discuss in later lessons in the future, like the importance of why we do this. But I guess long story short is because it's going to be easier to simplify things in the future. Okay? And what we want to do to factor is going to be the rest of this lesson. So here's our first example. Here we have 2x to the fifth plus 4x squared plus 12x. And the question is, how do we go backwards? How do we get something outside of the parentheses and then something left over in the parentheses? Well, what I want to do is I want to find the greatest common factor of each of these three terms. So we were asking ourselves, what is the greatest common factor of 2x to the fifth, the 4x squared, and the 12x? Well, as far as the numbers are concerned, we have a 2, 4, and a 12. And the 4 can break down to be 2 times 2. The 12 can break down, we have 2 times 6. The 6 can break down to be 2 times 3. So for the 12, we have 2 times 2 times 3. So for the number portion, what factors do they have in common? Well, the only thing they have in common is a 2. Right, they all have 1, 2 in common. So the GCF, looking at the number portion, would just be a 2. And now looking at the variable, we have x to the fifth, x squared, and an x. What do they have in common? Well, they all have one x in common. So the GCF of all of this would be 2x. So now what do we do with that 2x? Well, we are going to pull it out of this expression up here. So we're going to pull out a 2x. And then we're going to be left with something in parentheses. So what's in parentheses, you need to find that by thinking backwards. So think of backwards distributing. So you're asking yourself, 2x times what would give me 2x to the fifth power? Well, 2x times what would give you that? Well, if we had x to the fourth power, we now have 2x times x to the fourth would give you 2x to the fifth power. So that first term would be x to the fourth. And then plus, we need to ask ourselves, what do we need to multiply 2x by? 2x times what would give you the 4x squared? Well, 2 times a 2 would give you the 4. And then to get x squared, we need to take the x times it by another x. So 2x times 2x would give you 4x squared. And then we ask ourselves, what do we need to multiply by to get to this last term of 12x? Well, 2 times what would give me 12? Well, that would be 6. And then x times what gives me x? Well, just leave it as it is. 2x times 6 would be 12x. So this would be your solution. 2x times x to the fourth plus 2x plus 6. This would be your factored form of the original expression. Here's another example. Now we have 20a squared b to the fourth minus 30a to the third b to the third. And the first question is, what is the greatest common factor of each of those two terms? So looking at the number, we have the 20 and negative 30. What is the greatest common factor of 20 and negative 30? You maybe can just see the answer in your head already, But if you don't, you can work through it to get your solution. So looking at 20 and 30, we can break down the 20 to get 2 times 10. 10 can break down to 2 times 5. So now we have 2 times 2 times 5. 30, we have 2 times 15. 15 can break down to be 3 times 5. So here we have 2 times 3 times 5. So the greatest common factor would be found by seeing what factors do they have in common. Well, they both have a 2 in common, and they both have a 5 in common. So my GCF, looking at the number portion, would be a 2 times a 5, which would be 10. Now looking at the variables, we have a squared and a to the third. So looking at the a's, we ask, what do those have in common? Well, they both have 2 a's in common. So we have a squared as part of the GCF. And then the b's, here we have b to the 4th power. Here we have b to the 3rd power. What do they have in common? Well, they both have 3 b's, so they have a b cubed in common. So my GCF would be 10a squared b to the 3rd power. And now the question is, what do we do with that information? Well, we're going to pull that out of the original expression. So we have 10a squared b to the 3rd, and now we pull it out, and we're left with something in parentheses. So to find what's left in parentheses, we think backwards distributing. So 10a squared b to the 3rd times what would give me this first term of 20a squared b to the 4th. Well, 10 times what would give me the 20, and that's going to be 2. Then we ask a squared times what gives me a squared. Well, that's just going to be a 1, right? So the a squared is good. And then b to the 3rd times what gives me b to the 4th. Well, we need to put a b in here because b to the 3rd times b would give me b to the 4th. So that would be to get my first term. And then we ask ourselves, what do we need to put in here to get our second term? And there's a minus sign here, so it's going to be minus over there. And then we say 10a squared b to the 3rd times what would give me 30a cubed b cubed. Well, 10 times a 3 would give me the 30. A squared times one more a would give me a to the 3rd. And then the b to the 3rd is good. We already have b to the 3rd here, b to the 3rd here, so that's going to be okay. So my solution would be as you see right there. 10a squared b to the 3rd times parentheses 2b minus 3a. Now, using what we just learned with factoring, we're going to teach you how to factor by grouping. So here we see x times y plus 3 minus 4 times y plus 3. And this is exactly the same concept that we just was using, where to factor, in this case, we want to pull out what they have in common, the greatest common factor. Well, notice they both have a y plus 3 in common. So what I can do is I can pull out or factor the y plus 3, and then I'm left with something in parentheses, just like we had in the other examples. So what is left in parentheses? Well, in this scenario, when you're grouping, it's just going to be the x and the minus 4. So whatever's left over, it's going to be in the other parentheses. So my solution would simply be y plus 3 times x minus 4. Let me show you another example. Here we have u squared times 2y plus x plus 3 times 2y plus x. So when you factor by grouping, you can pull out what they have in common. Notice both terms have a 2y plus x in common. So I can pull out that 2y plus x. And then what is left over in parentheses? Well, that's going to be whatever's left over, the u squared and the plus 3 in this case. So my solution would be 2y plus x times u squared plus 3. Now, the question is, what if it's not grouped together already? So for example, 6xy minus 2, and then minus 3x plus 4y. So what I want to do, if you have something along these lines and you're told to factor by grouping, what I can do is I can group together 2 terms and then another 2 terms. And so there's different ways you can do this, different ways you can group together. So here's the first method, the first way you can group this. If I wanted, I can bring the 3x over next to the 6xy, such as right here. So I just bring the negative 3x over, and then the negative 2 put out here at the end. So I just changed the order of my subtraction. I didn't really change the original question. And what I would like to do is group together the first two terms and the last two terms. So I do that, and then I want to factor out something in common for each of these parentheses. So just like we did in the first set of problems, you want to see what they have in common and factor out what they have in common. So looking at the 6xy and the negative 3x, notice for the numbers, the GCF of 6 and 3 would be a 3. And then the GCF of the xy and x, notice they both have an x in common. So the GCF of 6xy and negative 3x would simply be 3x. And then over here, the GCF of 4y and negative 2, well, looking at the 4 and the 2, the GCF, the greatest common factor of 4 and 2, would be a 2. They both have a 2 in common. So for the first one, I pull out a 3x. The second one, I pull out a 2. What I'm left with in parentheses for the first one, when I pull out a 3x, would be a 2y minus 1. Right? I think through reverse distributing, 3x times what would give me a 6xy? Well, 3 times 2 gives me a 6. X's are okay. We need another y in here to get a y back out. So when you distribute, you get back the 6xy. And then 3x times what would give you a negative 3x? Well, that's going to be a negative 1 right there. 3x times negative 1 would give you a negative 3x. 4y minus 2, when I pull a 2 out, I'm left with, in parentheses, 2y minus 1. Because 2 times 2y gives me a 4y. 2 times negative 1 gives you a negative 2. So notice I had to group together first, and then I factored, and then I need to factor one more time like we just did in the last example, where notice they both have a 2y minus 1 in common. So what I can do is I can pull out that 2y minus 1, and then in parentheses, the other parentheses, I'm left with what's left over, the 3x and the plus 2. So this here would be my factored form. This would be my solution. I factored by grouping. Now I'd like to show you another method for doing the same factoring process to show you that you can factor different ways. And we can group together the terms differently and get the same solution. So you might be asking, okay, why could I not just group together the first two terms and the last two terms? Well, when you're grouping together, notice the process that we had where we pull out what they had in common for each set of groups. So if you group it together like this, yes, the first term you could pull out a 2, but notice the second set of terms, 3x plus 4y, there's nothing in common that we can pull out, that we can factor. So that is an issue, which makes it where we cannot easily factor that way. So for the second method, though, I can rearrange differently, and instead of putting the 6xy with a negative 3x, I could put the 6xy with the 4y. So I could put the 4y here, and then the negative 3x minus 2 together. Okay? And I guess even here, when we group this, when we group these together, the second set of terms, I guess, still really does not have anything in common to factor out. But there's some cases where it might be more difficult, and some cases where it might be more easy to factor. And if we were to look back up here, grouping like this, yes, it would work. We could make this happen, where we factor 2 out, and you're left with a 3xy minus 1. Then over here we have something, but it's not going to get you the solution easily, and I guess I would argue it might not even work, because you want to get to the point where you have something in common here and here. If you factor it or group it like this, it's not going to get you anything in common when you pull things out. Okay? So over here, though, it will. There's another way we could do this. where looking at the first set of terms, 6xy and the 4y, the GCF of those two terms would be a 2, and then they both have a y in common. So we can factor out a 2 and a y. Okay? And then in parentheses over there, we're left with 3 and an x, and then plus 2 in parentheses. Okay, because 2y times 3x gives you 6xy. 2y times 2 gives me a 4y back out. So that's going to be the first part, and I'll show that in a second. But I want to point out also when I group together the second set of terms with the negative sign here. Okay, notice that what I have is actually not what I originally started with, because what I have is a negative 1, which would distribute through the 3x and the negative 2. So negative 1 times 3x gives you a negative 3x, which is good. That's okay. But the negative 1 times a negative 2 gives you a positive 2, which is not what we had initially. We had a negative 2. So when I have a negative out here that's connecting the two binomials that I'm grouping together, then make sure you change the sign here in the center. Make that into a positive if it was a negative, and if it were a positive, make it into a negative. So change the sign here, and you're going to get 2y times 3x plus 2, and then minus, and then 3x plus 2. Okay, now notice we do have a 3x plus 2 in common that we can group out, we can factor out. And when you factor that out, in the other parentheses, I'm left with something. And what am I left with? Well, I have the 2y left over, and then minus, and there's an assumed 1 here. If it's not written, there's an assumed 1. So we have 2y minus 1. And notice I get the same solution. It doesn't matter the order in which I multiply. 2y minus 1 times 3x plus 2 is the same thing as 3x plus 2 times 2y minus 1. Now one last example I need to show you, and it's a little technique that will help you group factor by grouping certain expressions, ones that might be more difficult or maybe not as obvious. So here, okay, we see that it's already grouped together. We already have parentheses, and yet it's not the same thing in the parentheses. Here we have a y minus 1. Here we have a 1 minus y. Well, notice we are very close to having the same thing in parentheses, where the only thing that's different is the sign. Here's a positive y over on the left, positive y. Here's a negative y. Right here is a negative 1. Right here is a positive 1. Notice the only thing different is the sign. So a technique that I can use is basically I pull out a negative. I divide everything in here by a negative. I factor out a negative 1. So if I pull out a negative 1, so pull out negative 1, this now becomes a negative 2 times a negative 1, which becomes a plus 2. When I pull out a negative 1, it changes the sign of everything in the parentheses to become a negative 1 and a positive y, or positive y minus 1. And now we have the same thing here and here. We can factor the y minus 1 out, and in parentheses I'm left with an x and a plus 2. And once again, if you don't see that, you can maybe double check to confirm that we actually do have the same original statement. Because up here, if you were to distribute originally, negative 2 times 1 would give you negative 2. Negative 2 times a negative y would give you a positive 2y. Well, notice that's what we have down here. When I pull out the negative, change this into a positive 2, change this into a negative and a positive. 2 times negative 1 is still a negative 2. 2 times the y is still a plus 2y. So I do have the same thing when I change this sign out here, then change the signs on the inside. So a little technique you can use when you notice that you almost have the same thing in parentheses, but it's not quite. It's only differing by the sign. And that concludes our lesson for today. So we will see you next time.